Okay, now we're going to do operation 2. So let's hide this instance of the device, show the next one. It helps with visualization. And again, for this operation, we can keep our origin on the machine in the same place if we set our origin on the bottom left corner. We don't have the stock. We will need to use the stock model for the first routine, but before we turn it back on, we need to set our origin and do our setup, which is going to be based off machined edges. Okay, to set our origin for these other operations, because we have this chamfer, we don't have a selection point. So Fusion gives you some canned options which works, like the stock box points and the model box points. But we actually want to clamp onto this edge that, even if we go off model box point, is basing it off a corner that's out here because that's the extent of the model. In this case, we want our origin to be placed on the fixturing in the corner. And what we have is a chamfer here that won't allow us to select that corner. We can do selection, but we need to create something that we can pick on there. So what we can do is we can go back to our model. If you made this model roughly how I did, this was based off a sketch and the chamfer was added later. So if I go to my first sketch, it has that intersection. So I'm going to make the sketch visible, and just temporarily. And then if I pick out in space, you can see this purple edge is the corner I want. In another operation, we're going to want this corner. Okay, so we'll leave that visible for now. It'll give us some pick points. Setup, we're going to create a new setup. And we're going to start with our orientation. So the orientation is not going to be model origin. We're going to do z-axis and x-plane. So we pick on the top of the model for our z-axis. Our x direction is going to be along the edge of the stock there. We don't want to change this until we've selected what is our model. So we need to hit select and pick on our model body. And this will allow us to change the selection mode to a selected point. And we're going to make the stock temporarily invisible. And then you're going to pick our location, which is going to be, right now mine happens to be snapping to the right spot, but we're going to pick on that corner that is that intersection that's on our sketch. Okay, and so that's where my origin is. Okay, it happens to correspond where my model origin is, and so it may not appear like yours if you happen to put your origin on a different corner than I did. Okay, now we're going to go to stock, and we're going to go ahead and use from previous operation. And then we're going to go to post-process. We're going to call this 7310-2. Okay, it's the second program. We're going to call this op2. And we're going to use WCS1. That's it, okay. And we're going to rename the setup op2. Now we're going to turn our stock back on temporarily. Okay, we're going to recycle some of the toolpath from the other side. So this facing operation, we're going to temporarily turn on the stock, and we're going to copy the facing operation from the first side. Right click on that. We're going to do copy. Click on op2. We're going to do a paste. And then we're going to right click on that toolpath and go edit. And on geometry, we're going to keep the stock selections. And we're going to go to heights, and we're going to need to change some stuff here. Okay, we're going to go from stock top, and our top height is going to be stock top as well. And our bottom height is going to be model top, but we're going to leave about 40 thousandths. It's a millimeter to the top of the part. So if we look at this from the side, we should short stop of the radius about 40 thousandths. Stop clear of it about 40 thousandths. Okay, and on the next tab, we're taking off more material, so we are going to take a look at this. We got our pass extension, which is good. Our step over is fine. Direction in both is fine. We're going to use multiple depths. And our maximum step down is going to be a little bit bigger than that because we're using a 1/2 inch end mill. So we're going to go 0.25, which is half a diameter. We're going to attack the material from both sides. And we're going to do a finishing step. And we're going to use even step downs. And our finishing step down is going to be 10 thou. Actually, we're going to make it 40 thou. Okay, we're going to go to the next tab. We're going to keep all of this at default and hit OK. Okay, so we only ended up getting 2 passes out of that, but that should deck down the material. It's held pretty well in the vise with that large of a piece being held into the vise. We've cut pretty much all the way around the perimeter on this thing already, and we've milled down most of the material. So our perimeter is pretty close to this, only the top is flat. Now we're going to do our 3D moves to machine this surface here. So there's a variety of different commands you can use. And I'm going to use the parallel command, which is parallel to a side. Okay, so we're going to pick parallel. We're going to use the 1/2 inch ball. The larger the diameter of the ball cutter, the smaller the scallops, or the flatter the scallops are. So in theory, you get a better finish. So we're going to go to the aluminum library. We're going to use the 1/2 inch ball cutter. And we're going to hit select. We're going to do a rough cut first, leaving some material, and then we'll come back and do a finish cut. That way we have a consistent load on the cutter at any given time. So what we're going to do is we're going to go leave this all at default, and we're going to go to geometry, and we're going to try to leave the boundary on silhouette. No additional offset. Okay, contact only with the boundary. We're going to turn on slope. It's going to cut anything from 0 to 90 degrees. Rest machining we'll leave alone. And the model surfaces we want to cut. We just want to cut this one surface. Okay, we're going to change our tool boundary to outside the boundary. And we're going to select this button that says contact point boundary. That way we don't leave a scallop on the corners. And we're going to avoid some surfaces. So we're going to add a selection set to avoid. We're going to pick on the avoid icon, and we're basically going to select all of our vertical exterior surfaces. We don't want the ball cutter rolling over and cutting those. And we're going to avoid those by 1/10. So 4 zeros and a 1. And OK. Okay, now we're going to move on to the next tab. which is heights. We're going to the heights tab. We'll just leave these at stock top. That's fine. A selection point, which is the lowest point of the surface we're cutting. And then we're going to subtract half the diameter of our ball cutter. So negative 0.25. So it'll allow it to roll past tangency if it needs to. Okay, then we're going to go to passes. And I'm going to actually set a pass direction as one of the edge lines. We're going to go in both directions, and we're not going to do multiple depths. We're going to do stock to leave on this first one. We're going to leave 40 thousandths, not 4 thousandths. And we're going to turn on the smoothing deviation. Let's do 60 thousandths, not 600. And then we're going to go to the linking tab. We're going to leave all this at default. And we can leave the vertical lead-in radiuses on in this instance. That should help. We're going to select OK. And here's our cuts. What we do need to watch is like this area over here on the right where it's going to dive down. It might hit a little more extra material there, but this is a pretty good sized cutter. After it does its first pass, it should be pretty good. Now we're going to copy that routine. We're going to use a duplicate, and we're going to modify it to do our finish cut. Okay, at this point, we want to go fast. We've removed most of the material. We want to fine finish. Okay, so we're going to bump our RPM up to 5,000. And then our cutting feed, we're going to increase that to 50 inches a minute. Our ramp rate, feed rate, and our plunge rate on a surface cut is actually sideways, except for the very first move. So we're going to go 50 inches a minute on 50 minutes a minute on that one. Now, it's really important that you remember, if you do a routine after this, to slow it back down to the defaults for other things. Okay, let's go to heights. We're cutting to the model surface. This all is going to stay the same. We're going to go to heights. We're going to leave all this at default. We'll leave this selection the same on this one. Technically the lowest the cutter can go is that blue plane. Probably won't go to it anyway. We're going to go to passes. This is where we're going to change our step over to be 10 thousandths. And we're not going to leave any stock in this instance. We'll leave our smoothing on. Go to the linking tab. We can leave the vertical lead in, that's fine for this. And we'll hit OK. So we get a fairly fine step over. It's moving pretty quick. According to my time calculation, that run routine is 12 minutes. So, but it should give us a pretty good surface finish. Okay, so now we're going to do the text. So we need to go and make a sketch visible. Second to last sketch in our model if you project it the way I did it. Okay, so it shows up as magenta, pink, whatever you want to call that, letters. Okay, what we're going to do is we're going to do what's called a trace command. So we're going to go to 2D trace, and it actually follows the 3D shape. Okay, and then we're going to go select from our tool library the tool 17, which is our engraving bit, 1/8 inch diameter. Hit select. And we're going to keep all the default feeds and speeds here. And then we're going to go to the next tab, which is the Geometry tab. We are going to just skim the surface, and then due to how light we need to go to have this text show up, we're going to just adjust that at the machine till it's barely cutting in the surface. So I'm going to actually have you program this so that the text is right on the surface, and chances are there's going to be enough variance between the cutters that you may get it engraved just fine with that, or you may need to adjust this cutter down at the machine. And that's a reason to have this as the last routine as well, so we can restart it. Just leave the feeds and speeds as they are. We're going to go to geometry, and we're going to select our text. So we're going to go to the top view. We're actually going to see if we can pick the entire sketch. So expand the sketches. We're going to highlight the sketch. We should get all the geometry within it. Remember, your text has to be exploded, so if you didn't explode the text when you made it, make sure you've done so. So this makes it easy if it's clean and it's the only thing in the file. And then we're going to go to Heights tab. We can go ahead and leave this stuff at default. On the Passes tab, we're going to leave all this at default. Let's check the smoothing box. We could put an axial offset here. This would be a negative number. So you could put negative 1,000th. But I would rather have you come out with the lettering too light on the first pass and do some adjustments in the machine than have this not come out nice. So we're going to go to the linking tab. And we don't want to lead ins and lead outs. We'll just gouge our part on this type of thing. You can set a preferred lead in position, but I'm going to just hit OK and see what we get. Okay, so we get centerline toolpath. It should be three-dimensional. Even though it's a 2D command, it follows the curvature of the surface. Okay, we're going to go and move on to our next operation. Okay, operation 3. Go ahead and hide the sketch for the engraving since we're done with that. We're going to move on and hide the current vise setup and move on to operation 4's vise setup. Okay, again, this is a shorter parallel, so you need to keep track of this when you run it. The 1 5/8 are the tallest we have. There's one set at each machine. The other parallels are in a set that you in a red box, and you'll have to ask for them. We're going to kind of keep control of that so we can double check your work. And so we should be using the 1 1/8 parallels. The main thing is that this the crest of this arc is on the rear vice jaw. Okay, we're going to do our new setup. So we're going to go new setup, and we're going to go to stock, and we're not going to base it off the previous. We're going to go off solid, and we're going to select the part because there isn't any stock left on the exterior. It's the part minus these holes here. And we're going to go back to the setup tab, and the model is also going to be the body of the part itself. So in this sense, they're kind of one and the same. Okay, now we're going to set our orientation. We don't want it where it is right there. We're going to go Z-axis plane and X-axis. We're going to pick on the top of the part, set Z, and we're going to set X as the horizontal line on the part. And then we're going to go to a selection point. We're not going to use a box point. And we're going to pick on this corner of this sketch that we have. And that'll put it down on the bottom of the parallel. So that way we don't have to change the height when we flip this over for the the next operation. We use the bottom. Alright, so we got that covered. We're going to go to post-process. We're going to call this the 7310 op3, so that's going to be 3. Program comment op3. work coordinate system 1. We're going to hit OK. That should set our new setup. We're going to change the setup name to op3. Be consistent. And what we're going to do here is we're going to machine these holes. Okay. And I do believe we have a 1/2 inch drill bit in our library. And if we check this hole diameter, it is 547 thousandths, so it's bigger than a 1/2 inch. So there's a couple approaches we could take. We could just circle and interpolate these, don't worry about a drill bit, and pocket them. And then the other approach is we rough them with a 1/2 inch drill bit, and then we come back and do a contour with a smaller cutter. Drill bits are the most efficient way to remove material for this type of operation. So we're going to go ahead and drill it first, and then we're going to come back and open the holes up. We're going to drill each one. We're going to spot drill each of these locations. We're going to drill each one of these locations. We're going to profile the inside of the hole, and then we're going to use a chamfer mill to do the chamfer on the edges. Okay, we're going to go to drilling, and we're going to select from our library our 3/8 spot drill, and then we're going to select the chamfers. Cut this actual chamfer, but it will spot drill down to a certain depth, and based on the centers of it, because this is only a 3/8 diameter spot drill. What a spotting is actually a spot drill is actually a little cone cut that's slightly bigger than the web of the drill bit. The web is the very center of the tip before where the two flutes come together, and it's ground sharp there. So we don't have to go very deep. We've been going deeper on other things just because it's convenient to make the countersink, and we're not going to be able to do that. So we're going to go to our heights tab, and we're going to go from model top, and the actual cut is going to be from hole top, but we're going to base our depth off also hole top, and we're just going to punch in a number. Now let's look at what our peck depth is with this cutter. If we go to the deep drilling, it normally pecks at a 93 thousandths peck. So let's just do that. We're going to go back to drilling, and we're just going to do 1 peck on it, and we're going to go negative 0.093. Okay, and then we're going to get a little dimple there that our 1/2 inch drill bit will self-center on it. Okay, we're going to go to the next tab, which is cycle. Leave that at deep regular drilling. We don't need to do a peck, it's only doing 1 pass. And we go to linking, and then we're going to hit OK. Okay, so we should have a little cone at the top of each of the holes.